Hello dear students, let's return to decision properties of CFG. The third property that we will see is emptiness. The problem is, as you know, we are given some context-free grammar and we want to know whether the language generated by that grammar is an empty language. That means we want to ask, is nothing generated by CFG? That means CFG does not generate any strings. That means LG is a null set. It would be nonsense CFG because if context-free grammar doesn't generate anything, then it is useless. But then we should try to figure out, is this problem solvable? Is there any strict algorithm or a method by which we can check whether the grammar is empty or not? Okay, and there exists an algorithm, and we have already seen how to check emptiness in simplification of CFG. Just check, given a grammar, now it can be Chomsky normal form or it can be simple CFG also. In this case, it need not be CNF, but I have written a CNF. Given a grammar, you try to find out useless symbols in the grammar and remove them and remove the useless symbols. Remove useless symbols. While removing useless symbols, it may happen that ultimately, you know, start symbol S itself is removed. Oh my God. You just tell me, if the start symbol S itself gets removed, saying S is also useless, then the entire grammar is useless. Nothing will be generated by the grammar, correct or not? Just observe this. Just observe this grammar. It is so easy to find out that B is useless. Because, just check, if we start the derivation, let's say S gives AB, this is the start symbol. Now A will give A, nice. A will give small a. But what will B give us? B will give us BB. Again B will give us BB. This is senseless, because B is not generating any terminal and it will keep looping forever. That means B is useless. So what we will first do is we'll remove the production for B, but you know B is useless. Just check, how can B be there anywhere on the right hand side? So you will remove this right hand side also. But if you are removed this right hand side, then S generates nothing. Are you understanding? The production for S itself is meaningless now. What happens when you try to find out some useless symbols? You keep deleting useless symbols, and it figures out that even start symbol is useless, because this B was useless, so you can't keep this production. And when you remove this, then S doesn't derive anything. If S start symbol doesn't derive anything, then the language is empty. I hope you have understood. So what is the method to check emptiness? Just find useless symbols that we saw. This topic we saw in the simplification of CFG, correct? But we did not see emptiness. I gave such examples where S was not empty. Here, this was an example where S is empty, isn't it? As another example, just imagine we have a grammar like this. Now I am taking a simple CFG, okay? S gives A, B, B, let's say. And A gives AA or A. And B gives, let's say, B gives BB. Just check this. This is the grammar given. Very quickly find out that B is useless. Because if you start the derivation, S gives A, B, B. And in the next step, A can either give AA or simply A. So I'll say A gives A. That's it. So AA is done. But what will B give us? B capital B. Again, what will this B give us? B capital B. Again, what will this B give us? B capital B. That means this will loop forever. And we have no other option escaping B. That means B is useless. It is not generating any terminal. So about to delete this. But then B occurs here also. You just can't delete B. Hello. This is senseless. You will have to remove this entire production. But if you remove entire production, S is left empty. Nothing is generated by S. And this also becomes senseless, of course. S itself becomes empty, then the language LG generated by this grammar is empty. So the grammar written was next to nonsense by someone. This grammar was next to nonsense because this is not going to generate any string. I hope you understood that decision property called emptiness is solvable. We can write a computer program or an algorithm which will check useless symbol and then find out whether S becomes useless. If S is also empty, then the language is empty. Okay, so we have seen all three decision properties: membership, finiteness, and emptiness are solvable. The answer to this problem is yes, there exists an algorithm. Yes, algorithm exists for these problems. So decision properties are solvable. Thank you very much.